Hi, this is Sung. I'm the director of Sky Academy, and in this episode, what I want to do is kind of move towards finishing off plane geometry. And to do that, there's pretty much two things that we need to do, still need to cover. The first thing is to deal with area, okay? And to make sure that even though you may have done it in your junior years, I want to make sure that you've covered it, and that is how to find the area of some common shapes. Yeah, so some of the common shapes that we need to find the area of include triangles over here, quadrilaterals and special quadrilaterals in particular, and then circles and sectors. Yeah. All right. Now let me just say that we will go through a more in-depth way of calculating the area a little bit later on when we do integration. And then when we do approximation of area, techniques for approximating area like Simpson's rule and trapezoidal rule, which is in the integration topic, we will look at more closely how to find the area of some irregular shapes, all right? But in this particular unit, we're really only looking at some common garden household variety shapes that we've got, okay? So let's just launch into it. Basically what area is, and before we really start finding, going through the formula for how to find the area of different shapes, I want to actually distinguish between area and perimeter, which is basically, two concepts and two ideas that you will have covered in your junior school, but I want to make sure that you've fully covered it before we move on, because I don't want you getting confused about these two things. Now, area is simply the amount of space, or two-dimensional or flat space in a two-dimensional shape, whereas perimeter is the distance around a shape. So basically, if you were a little bug, right, perimeter would be if you were to take a little walk along the edge of the shape back to your starting point, then it would be the total distance that you walked. Whereas area would be how much space you have to play inside that shape if you were a little bug, to move, to have fun and to just enjoy the area like it was a playground, okay? So that's the difference between area and perimeter. Now, the other thing that I want to also go through is the word circumference. Now, circumference is a special word that we use for the perimeter of a circle. And the reason why we use the word circumference, I think, is because circumference entails the idea that you're walking around a curved edge rather than a straight line edge, which is really what perimeter is about, okay? So oftentimes we use circumference for the circumference of a circle or the circumference of an arc. When it comes to sectors, we often use the word perimeter because the perimeter of a sector includes both the straight edge and the curved edge, and altogether perimeter might be a better word to use, right? So I just want you to be familiar with when to use the word circumference, when to use the word perimeter, when to deal with area. Okay, so let's have a look at the area of some common shapes, and we'll start with some quadrilaterals first, okay? Some easy quadrilaterals. The first one is a square. The area of a square is basically s squared, where each side is s units long, all right? So area of a square is s squared, okay? Where s stands for the side. The area of a rectangle, all right, is length times breadth, where one side is the length, the other side is the breadth. The area of a parallelogram is base times perpendicular height. The perpendicular height being not the slant height, but the height that is directly 90 degrees up from your base, all right? And the base is basically the side on the very bottom, okay? So base times height. Now, that's your basic way of finding the area of these three quadrilaterals. This sets us up to find the area of a triangle. Now, for a triangle, the area of a triangle is half the base times perpendicular height. So you've got your base along the bottom, you've got your height, your perpendicular height, which is given by a line that goes from the apex, which is the top of the triangle, to the base, right? And that line is called your altitude. So we're dropping an altitude, and that altitude represents the perpendicular height of that triangle, right? So you're basically, the area of that triangle is base times perpendicular height. And you can easily show that by drawing a rectangle around that triangle and saying, well, that triangle can be represented by this right angle triangle and this right angle triangle. If you add these two smaller right angle triangles together, right, then that will represent the area of the bigger triangle. And what you'll also notice is that when you add these two, each of these two smaller triangles is half the rectangle that it sits in. And when you add those two rectangles together, you get the bigger rectangle. Therefore, the bigger triangle is half the bigger rectangle. Okay, so basically that's how that works. So you've got, so your area of a triangle is half base times perpendicular height. And this sets us up nicely to find the area of the rhombus and the kite, right? Because both these areas you can find by adding up each of the triangles inside the rhombus and the kite, where you've been given the diagonals, right? So you can work that out later if you really want to, but if your two diagonals are x and y, so y being from one tip to the other tip of the rhombus, and that distance is y, and the other tip to the other tip, that distance is x, so your two diagonals are x and y, the area of a rhombus is half xy. And the same will be the case for a kite, all right? So from one tip to the other tip is your x, one tip to the other tip is your y, half xy is the area of the kite. For the area of a trapezium, right, you basically have your perpendicular height, h, and you have two parallel lines. One will be longer than the other one, all right? To find the area of a trapezium, you add your two parallel sides together, all right? X plus y, multiply by your perpendicular height, and then halve it. So A is equal to h on 2 times, open brackets, x plus y, close brackets. So that's the area of a trapezium, right? Finally, we get to the area of a circle. The area of a circle is given by pi r squared, and you will have seen that from year 8. And I want to distinguish that from the circumference of a circle, which is 2 pi r, or pi d, where d is represented by the diameter of the circle, and the diameter will always be 2 radiuses long, okay? And then you have the area of sectors. Now, common sectors include semicircles and quadrants. So basically a sector is like some portion or some fraction of the circle, right? So if you've got a semicircle, it's basically the area of a circle, pi r squared, halved, because it's half a circle, whereas a quadrant will be pi r squared divided by 4 or over 4 because it's a quarter of the circle, right? So you're dividing the circle up into 4 equal parts. Where you've got an unknown portion given by a specific angle, right? The area would be that angle over 360 because there's 360 degrees in a circle. So that angle over 360 gives you that portion times by the area of the circle, pi r squared. Got it? So that is basically how to find the area of some household shapes. The last thing you've got to be able to do with all those household shapes is to use all those formula to be able to find the area of composite shapes, because sometimes questions will be given to us where we actually are given a composite shape or some irregular shape that can be broken down into all these different other shapes. And to find the area of a composite shape, we find all the areas of the shapes that we do know, add them together, and that will give us the area of that composite shape. Okay, good. Thank you very much for watching. In the next episode, what we'll be doing is looking at volume and surface area of 3-dimensional shapes. Thanks again. Bye.